afternoon, everyone. Welcome to the last slot of the day. I'm sure you're probably all tired from a long day of learning, so I want to thank you for spending the time in the last session with me. I know there's a lot of other tracks you could have gone to, but hopefully we'll end this day on a high note and have some fun. Now that most of us are here, I was hoping we could lock the doors and try and break up, but I guess that's not possible, so I need a volunteer. Kidding. In this session, we're going to be talking about how building a portable escape room improved my skills as a developer. And along the way, I'm going to take those learnings and see how we can apply them to real-life development scenarios as well. So hopefully when you come out of this, not only will you have had a good time, but you'll also gain some knowledge at the end of it too. My name is William Brander. I work for a company called Particular Software. We make NServiceBus. If you haven't heard of NServiceBus, it is a framework and corresponding set of libraries that help developers distribute their systems in .NET. Whether that's microservices or geographic redundancy, whatever it is, NServiceBus can help you do that. But we're not talking about that today. So in addition to working for Particular, I also spend way too much of my money helping escape room owners retire. I love doing escape rooms. There is nothing that I enjoy more than going somewhere new, finding an escape room, and doing it with a bunch of friends. I live in Johannesburg, and there's probably only about 2 or 3 escape rooms here that I haven't done yet, so I need to ration them out for special occasions, unfortunately. But I love them. In fact, I've done an escape room on 5 out of 7 continents. North America will be solved next month, which just leaves Antarctica. Minor problem, because there aren't any escape rooms there, but I have a plan. What I'm going to do is change careers completely, become a research scientist, and go to one of the research stations there. As soon as I get there, I'll find all of the keys and access control mechanisms that I can find, throw them outside during a storm, thereby triggering a forced escape room with my colleagues. Talk about team building. If I were to do it, I wouldn't do it at the South African research station. This is the Norwegian research station, and this would be where I would do it because this is known as the troll station. And I can't think of a better place than the troll station to act like that. Side fun fact about the troll station, because Antarctica doesn't have daytime lines and it makes no sense, they have their own specific time zone called troll time, which again is probably the best time zone to live in. Now you might be asking yourself, William, why would you build an escape room? And that's a very good question. I should have thought that through a lot harder at the beginning, but I didn't. The reason I built an escape room is because of these two. These are my daughters, and I absolutely adore them. And they know that I love doing escape rooms. So naturally, they asked if they could do an escape room with me. Unfortunately, all of the escape rooms in Johannesburg are at a difficulty level where children won't enjoy themselves. They won't be able to solve any of the puzzles, and they'll just be dragged along and get frustrated. Which led me to think, well, maybe I can do something for them. Maybe I can build an escape room that they can do with their friends. And it'd be really cool if they could take it somewhere and do it at birthday parties or something like that. And that's what I embarked on. But now, before you start making an escape room, you kind of have to know what you want to make. So I spent some time thinking about what I enjoyed from escape rooms, the kind of things that excited me about them. And I made a list. The list starts with decor. I love these kind of over-the-top themed rooms. Like, if this is your room, please introduce yourself to me. You must be a really interesting person, and I want to meet you. But this is very clearly escape room decor. You can tell because there's a bunch of padlocks all around the room. There's weird pictures that say things like, hell hath no fury, like a scorned woman, or woman scorned. If this is hanging up on your house, again, please come talk to me. I want to know more about you. But what's interesting about this is that the hell is spelled like a weird upside-down 4, 3, 1, 1. Could be a clue for a combination. So I love escape rooms that stimulate the imagination. They give you a bit of a theme, and you immerse yourself in the room. I also really love when there's multiple rooms. So you solve all of the clues in one room, and you get to the end, and you open the door, and you're presented with a whole new room with amazing decor there as well. And you've got a whole new set of clues and puzzles you get to solve. If I can't do that for my children, I also want to be able to open lots of boxes, lots of devices, lift things up and discover things inside, things that are interesting. When you open these things, they must be visually stimulating. They must engage your senses. It mustn't just be about, oh, here's another box with a few buttons over here. Maybe some puzzles must involve your sense of smell, your sense of touch, your sense of hearing. It must be intriguing to use these puzzles. Most importantly, escape rooms must be finishable. That is not a word, but I'm claiming it. So finishable, and I don't just mean you must be able to complete the room, because if you finish the room in 20 minutes, that's not nearly long enough for you to be stimulated and engaged. Ideally, the sweet spot for finishing an escape room for me is somewhere between 45 minutes and 60 minutes. If I can finish a room in that time window, I've had a good time. In fact, some of the best rooms that I've done, I've finished at 59 minutes and 30 seconds, and we finally solved the last puzzle and had to sprint back to the front door to make it in time. That is absolutely memorable, and I love rooms like that. So that gave me my set of requirements that I wanted for my children's escape room. I wanted puzzles that are simple. And when I say simple, I don't mean easy. Easy and simple are different things. For instance, pushing a button is simple. It is also easy. Pushing a button that is hidden away behind laser tripwires, still simple, really hard when you're my age and you can't bend as well as you used to. I wanted the escape room to be finishable for the children, again, within a 45 to 60-minute period. I wanted different areas. So I wanted, if I ran the room at their friend's house, I wanted to be able to lock different doors and have them go into these rooms and discover new clues and puzzles. And if I couldn't do that, I wanted to have lots of containers that they could open and find things inside. And I wanted all the things that they find to give the kids a sense of wonder so that they enjoyed interacting with these puzzles and playing with them. Some optional extras that I wanted some replayability. I wasn't going to go through all of this effort to run an escape room once and be done with it. So I wanted to be able to run the room multiple times, probably for a large overlap group of children, so the same group a lot of times, but I want them to have a different experience each time, which means I also needed some of the puzzles to be reconfigurable. Maybe the one puzzle opened that lock on the first attempt. The second time they run the puzzle, it doesn't open anything, but it gives them clues, something like that. The hardest of these to achieve was the finishable aspect, because some children are really, really smart. And some children, I don't want to say they're not smart. I think perhaps a better way to phrase it is because all children are smart, they really are. As adults, we don't recognize their smartness yet. We haven't found out in which ways they are smart. And having a room that they can finish within 45 minutes to 60 minutes is really difficult if you've got a diverse group of children that you don't know how they think. What I decided with this was that I wanted to be able to have puzzles where I could change the difficulty. So I could make the room easier or more difficult as the children were playing through the room without them noticing that I'm changing the difficulty. So if they're going very slowly, I could make the following puzzles easier. Or if they're going really quickly, I could make the following puzzles harder to sort of keep them engaged in that time period window. Let's take a quick look at some of the puzzles that I made that are of interest for us today. So the first one I made was a balance puzzle. Or not the first one. The first one we're going to discuss is the balance puzzle. So this is essentially a 2D spirit level, and the children, or the players have to get it to be perfectly aligned in 2 dimensions for a certain period of time. I can change the difficulty of this by changing how accurate it must be, how close it must be to perfectly level. I can also change how long it must be on level before it unlocks whatever they had to do. And I could also change the number of targets. Oh, I didn't explain that, sorry. So I can also reconfigure this puzzle to, if I've got numbers stuck on the wall and you point it at the 9, it registers that as a success. And then a 6 and then a 3. That would then give you a combination 9, 6, 3. So I can change the number of targets that it must point at before it unlocks the next clue. I can also change how the device is manipulated. Now this, obviously I can't do on the fly, but if you're holding the device in your hands, it's very easy to get it exactly where you want. The children had to do it with little strings attached to it. If I was running this room for older players, I might have it indirectly manipulated via pulleys or levers or something like that, just to make it a little bit harder. That one I obviously can't change on the fly, but all the other 3 difficulty things I can change as I go. Then we've got a musical tone puzzle where there's a button on top. You push the button, plays a little musical song for you, maybe Twinkle, Twinkle, Little Star. And then all the numbers on the keypad correspond to a musical note, and they have to repeat that same song. I can change the difficulty here by changing the length of the song. Twinkle, Twinkle, Little Star is much easier than Twinkle, Twinkle, Little Star, How I Wonder What You Are. In fact, it's half as easy, twice as easy, whatever the fraction is. I can also change the randomness of the song. If it is a song and the children recognize the song, they can remember that song in their mind while they are pushing the buttons to hear the musical tones, and they can keep track of, oh, it's this note, it's this note. More easy than if I just have a song they've never heard before. Another puzzle that's relevant to what we're discussing today is something that I call Simon Says, where there's X number of devices between 1 and 5, and they've each got 2 buttons and 2 LEDs on. And the LEDs flash in a specific pattern. The players then have to repeat that pattern by pushing the buttons in that same order across the devices. I can change the difficulty here by changing the number of devices involved in the pattern. If I want to make it really hard, all 5 devices being involved, or if I want to make it easier, only 2 devices. I can change the number of buttons involved. Obviously, I can't take buttons out during the game, but I can, instead of using both LEDs on the device, only use the left LED, so they only have to remember the left button, which makes it substantially easier. I can change the length of the pattern they have to memorize, and I can also, keep the devices physically separated, so they have to communicate verbally and say, left, right, left, or whatever it is. That could make it quite hard for the players. Once they solve these, I need a way of dispensing the next clues. So some of the fun ways that I had was a little box with a maglock on. They solve a puzzle, something drops out. Yay. Treasure chest that opens up automatically once they solve a puzzle. There's a little servo motor in there. Pro tip, make sure you tell people don't force this open when they see it, because I have gone through 3 separate servo motors because people just rip it open. Then we get some of the more engaging ones, the more stimulating ones. I call this one the sword in the sheath, where there's a little maglock that I forced into the side of the sheath of the sword. It just holds enough magnetic pressure that children can't pull it out until it releases, and then they can pull the sword out and they can get whatever clue you've written on there. You don't just have to have combinations, you can write a whole little thing on the side of the sword with whiteboard marker and rub it off at the end. And then my absolute personal favorite way of dispensing clues is something that I like to call the catapult of splinters. So this is great. You load a little clue into the top part there. It's attached to the front by elastics, and at the back there's a small little string that keeps the tension on. The bottom of the string is attached to another servo motor that keeps that string at tension. Once they solve whatever puzzle they need to solve, that servo motor disengages, releasing the string. The delivery mechanism flies forward, whacks into the plank in front, and a piece of clue comes flying across the room. It makes a really loud noise when the wood hits the wood, which is great because the children have been concentrating so hard. This loud noise comes and something flies at them. I like to think what I'm teaching the children is that progress can be scary and achieving your goals is daunting. The thing that all of these devices have in common is I run them on little microcontrollers, ESP8266s or ESP32s. You don't need to know too much about it, but this is sort of what the development boards look like. These are really powerful because you can turn them into portable web servers. You can run C++ on them, BASIC, Python, JavaScript, a bunch of different languages, but you can turn them into portable web servers. So you can say things like, connect to the Wi-Fi network, and when you get an HTTP request on this endpoint for this HTTP verb, give a response in this manner. So you can use that to communicate with the devices and tell the device to turn things on or off, release things, shoot things across the room, whatever it is. The way that the devices do this is that in C++, there is a loop method, and at the bottom there's a server.handle client. And whenever it hits that bit of code, it goes and looks, well, is someone waiting for a response from me? Yes, they are. Let me go and do that response and send it back. The problem here is that this is single-threaded. And these devices are not only doing one thing at a time. What do I mean by that? So on the happy path, you've got an HTTP request that comes into your device. It gets to the server.handle client and says, oh, okay, cool, here's your HTTP response. Yeah, we're done. Except my devices are doing a bunch of other things. They might be, for instance, using this device to calculate its position in 2-dimensional space for the spirit level puzzle, the balance puzzle. Some of these devices that you can use have digital motion processing on, some don't. If they don't, you have to do that motion processing on the ESP, which means calculating the angle that it's pointing could take a long time. So if you start calculating the angle, single-threaded, and an HTTP request comes in, while it's busy calculating that angle, that HTTP request is sitting there waiting for a response. Once the angle eventually gets returned, that HTTP request could time out. So we've got a time-based linkage between when we make the request and if we're going to get a successful response. Because the caller, in this case, might think, oh, the device isn't working, which could be problematic. This is an example of temporal coupling. Was anybody in Mike's talk earlier? Another example of that. What would be better is if we had the device and it was doing whatever it had to do. It calculated the angle, took whatever time it needed to do that, and got the response. And afterwards, it said, well, what must I do next? Is there someone that I must send a response to? Now, because I work for particular software, we make NServiceBus, which works off of message queuing technology. For me, that meant, well, put a broker down. So for these devices, I used MQTT, which stands for MQ, ironically, transient telemetry or something like that. The Q is actually a misnomer as well because it's not a Q. The benefits of MQTT are that it's very lightweight, so it works quite well for these small, low-powered devices. It's reliable. You can define 3 quality of service. You can define at most once processing, at least once, and exactly once, which is pretty powerful for a broker. It's also standards-based, which means if you're using an instance of MQTT and you want to move to something in the cloud, as long as it supports the MQTT protocol, you should be able to move quite easily. There are a few downsides. Specifically, it's not actually a queue. So the queue length can either only be 0 or 1. You can never have multiple messages backed up, which means that if one device sends a message to a topic and the second device sends a message to that same topic before the subscriber has taken that first message off, that first message is discarded. So you can lose messages because you do not have an actual queue depth here. It's also got a slightly smaller feature set to other brokers, but we'll look a little bit later about how to work around that. So we've got these devices and they're talking to each other via MQTT. The instance of the broker that I was using is called Mosquito. That's sort of the premise. Now we're going to start looking at some of the lessons I learned and how you can use those in your day-to-day software development careers as well. And we're going to look for a few clues here. The clues we're going to look for is how you monitor systems like this, what systems like this can tell us about aggregate routes, how we can manage the flow of the escape room and how we can change the difficulty as we need to on the fly, and how we can work around the limitations of these low-power devices and brokers. Now, when it comes to monitoring these devices, like I said, they are very low-powered devices, so they fail fairly regularly. And when a device fails, it doesn't just fail, it usually fails and then resets. So when it comes back online, you have to check, well, why did you fail? Are you coming back online because of a hardware reset? Are you coming back online because of an exception, because of a watchdog timer, because you got turned off? There's a lot of things you have to check when you're monitoring these devices. So knowing about failures is quite important when you're monitoring these things. I also wanted to include some type of health check APIs. So there I would just have an HTTP endpoint that says, well, when I get a request here, return a 200 OK. Because MQTT only has 0 or 1 queue length, I also thought it would be cool to monitor the queue length. If a queue length stays 1 for a very long time, it means that there's nothing moving messages off of that topic. So that's a problem. But as I was going through this, I started thinking, you know, this is very mid-2000s, it's very low level. And in the mid-2000s, what you would do is you would have a web server and a database server, and your web server would talk to the database server, and you would monitor this by asking 3 questions. Is my web server up? Is my database up? And can my web server talk to the database? That's it. Monitor, tick. But I deal a lot with distributed systems, so I started thinking, well, these devices are kind of small. One might even say they're micro, and they certainly provide some sort of utility, maybe even a service of some kind. Maybe there's something I can learn from how you monitor microservices to how I can monitor these devices. And when it comes to monitoring distributed systems or monitoring microservices, there's 3 specific attributes that you need to be aware of and you need to understand. The first is the monitoring area. So what are you monitoring? Are you monitoring the infrastructure of your system? Are you monitoring the application of your system? Or are you monitoring the actual capability that the system exposes? Some examples of this. Are my devices online is monitoring the infrastructure of my escape room. Are my devices responding to publishers is monitoring the application of my system. Can players solve the puzzles is monitoring the capability of the application. If everything else is yes, but they can't solve the puzzles, it means that there's something wrong with the capability. It's not providing the experience that they need. So that's the first attribute, the monitoring area. The second attribute that you need to be concerned about is the monitoring concern. Now, the monitoring concern could be things like where you monitor the health of the system. Now, importantly here, there's a many-to-many relationship between the monitoring area and the monitoring concern. Specifically, you can monitor the health of your infrastructure. You can monitor the health of your application and the health of your capability. Same as the performance. You can monitor the performance of your infrastructure, your application, and your capability. And the capacity of your infrastructure, application, and capability. These are all 3 separate attributes, 3 separate concerns that map to all 3 of the monitoring areas. It's a many-to-many relationship between the 2. The third attribute that you need to think about when you monitor distributed systems is how you're going to interact with this monitoring. Is it going to be passive monitoring? Am I just going to look at the log files when something goes wrong? Am I every now and then going to glance up at a dashboard and see if everything's okay? Building on top of this, you can get reactive monitoring, where perhaps if the system picks up that the queue length is growing and growing and growing, it sends a push notification to the support team, maybe triggers a PagerDuty alert to tell you in advance, you need to do something about this. Something is happening and the system has reacted to tell you to fix it. And then we've also got proactive monitoring, where the system will try and address some of these concerns. If it notices that the queue length is growing and growing and growing, the monitoring system could proactively try and increase the concurrency of whatever's processing those messages. So proactive interaction types. With this framework in mind, let's take a look at what we were monitoring with the failures before and the health check APIs. So with the health check API, with just a 200 OK, what I was actually monitoring there was the health of my infrastructure. Is my infrastructure on my devices online? And this was passive because I was only doing this when things were going wrong. If I was monitoring the queue length in a normal system with a normal broker, I would be monitoring the performance of my infrastructure. With MQTT, however, I'm monitoring the health of my infrastructure again because the queue length is either only 0 or 1. Now, wait a second. Both of these were giving me the same things. I was monitoring the infrastructure and the health of my infrastructure. Why am I monitoring the same attributes twice? And in fact, the health check APIs were problematic because what was happening was sometimes my devices were connected to the Wi-Fi network, but there was a bug in the code and they weren't able to take messages off of the queue. So they were returning 200 OK, saying that these are OK, but they weren't actually processing any messages. So they would give me false positives to say that the system's fine, everything's great, when it actually wasn't. If I had canary devices, maybe I was walking around following my players and I had second devices that I was trying to solve the same puzzles that they were, and I noticed, oh, wait a second, something's not working there. Let me quickly swap these devices out. That's proactive monitoring at a capability level that I would be doing there. So when you identify your dimensions that you're monitoring, the attributes that you're monitoring, spend some time thinking about which of these attributes they are targeting. If you have duplicate ones, see if you can find out whether or not these duplicate ones are giving you information or if it's just giving you the same information. If you're monitoring large-scale distributed systems, you need to be aware of what you're monitoring because you get a lot of information, and not all of it is useful. So that's the first clue. Now let's shift and take a look at some DDD aggregate roots. And we'll start with the musical tone puzzle, because this is a nice analogy. With the musical tone puzzle, everything is self-contained within that device. All the logic is there. I can change the behavior of that device completely without interfering with the rest of the escape room. This device just has to know which key button has been pushed and whether it was the top button, and it needs to know what song it must play. All it has to do is, once the puzzle has been solved, once the correct combination has been entered, publish an event to say, yeah, I've solved this thing. Conversely, all it has to know about the rest of the room is it needs to subscribe to difficulty changes. So if something tells it, we need to make you easier, it just needs to subscribe to that. That's the only input and output that this device needs. The service boundary here is very well defined. And it's a nice metaphor for a service boundary because you've got this physical device. Everything is contained there. Conversely, if we take a look at the Simon Says puzzle, that is not true. If we had something that told our escape room to change the difficulty, let's say it created a message and published it to MQTT. All of these devices receive this message and say, okay, so what do? I need to know from the other devices what they're going to do so that we can all change our difficulty in tandem, which means that each device on its own is not in a clearly defined service boundary. And in fact, what I ended up doing was I had a concept of a primary device and secondary devices, where the primary device created a peer-to-peer network with the secondary devices, and the primary device was the one that subscribed to MQTT, which meant that if a difficulty change event came through, that went to the primary device. The primary device could then say, okay, secondary, from now on, we're only using the left button, and the pattern is going to be me, A, to A, me. So the primary makes all of those decisions. If the primary goes down for whatever reason, one of the secondary devices could resume that role of primary and set up a new peer-to-peer network between the remaining devices, subscribe to MQTT, and carry on. The key thing here is that the service boundary isn't at a device level. The service boundary is across all of these things. It is a distributed service boundary. However, the consistency boundary is the same. What do I mean by this? Well, the logic within all three of these devices, when they work together, is self-contained. The pattern that has to be completed, the logic within that service boundary can change without interfering with the rest of the escape room. The primary is the only one that needs to publish when the puzzle has been solved, and the primary is the only one that has to subscribe to difficulty changes, which means that across all three of these devices, the service boundary is well defined. Let's take a look at some real-world examples. The stock service and a user service, or an authorization service. The stock service says, well, this user wants to delete this item from the stock. Do they have permission to do this? And the user service says yes. Here's a problem with this. The logic is not self-contained within the stock service. The stock service needs input from the user service to know whether or not to go forward or not, which means that the service boundary is poorly defined here. Has anybody seen a system like this in production? You don't have to put your hand up, it's fine. Other examples might be if you've got an insurance system and you're processing a claim, and the claim asks the payment service, has the customer paid all their premiums? Again, you've got information that you have to get from outside of your service boundary. Maybe you've got an order service, and the order service has to ask the stock service, do we have stock of this item? Or how many items do we have in stock? The service boundaries here are poorly defined. Not always a problem, but the service boundaries are poorly defined. Now, you might think, well, if the service needs to go outside of itself to get more information, well, to fix that, I'll just make the service boundaries bigger, right? Ironically, it's the opposite. What you actually need to do is make your service boundaries smaller. For instance, instead of having a stock service that supported the capability to remove stock, you could have a stock removal service. What's interesting about this use case is that it doesn't need to know about permissions because the permission becomes an infrastructure concern. Does this user have permission to publish messages to this topic in my broker? That becomes infrastructure, not logic that you have to worry about in code. Maybe you've got some business rule that says, well, you can delete items up to 1,000 Rand in value. Other than anything higher than that, you need approval. Okay, you still do it in the stock removal service. You don't need to ask whether or not the user's got permission to access it. The user can because it's got permission to publish messages to this topic. And you're removing something. You're doing a verb instead of a noun. But what if the user tried to delete something worth 5,000 Rand? Okay, well, just accept it in the stock removal service, but instead of straight away deleting that item, send a new message to the approved stock removal service, where the managers have got access to receive messages off of that queue, and they can then process that information. And how do you know you've got access to that service? Because your client can literally make a request and get messages off of that queue. So making your service boundaries smaller, ironically, can help you eliminate the need to cross service boundaries. And the trick here is to think about verbs. What is your system doing versus nouns? Your service boundaries are business rules. And trying to just say, well, we're doing a stock service isn't going to help you identify those business rules. So we've taken a quick look at aggregate routes. How can we manage the flow of an escape room? We've got all of these devices and they're communicating via MQTT. How do we make the escape room easier or harder? Well, we introduce the concept of an escape room run. And an escape room run is a state machine because the escape room can be in 3 possible states. So at the start of the escape room, when the players start the room, they're on schedule. As they solve some puzzles, they still stay on schedule. As time passes, maybe they start falling a little bit behind until enough time passes and they are behind schedule. At this state, when we're in this state, we can start publishing events to say, you need to be easier, you need to be easier. Actually, you're not part of the escape room anymore. This puzzle is completely removed. So the state machine can publish those events to control how difficult the room is. They start solving more puzzles while they're behind schedule. They get easier and easier, and eventually they come back to being on schedule. Maybe now the room is too easy, and they start solving more puzzles, and they're ahead of schedule. We're in a new state now, so what we do is we start publishing more messages to say, now we need to be harder. Quick, you back in the puzzle now. And they solve puzzles, and time passes, and they get back on schedule. And ideally, we corral them into this 45 to 60-minute ideal time period. But ultimately, they could end the escape room on any of these states. So the escape room is a state machine that represents the entire room. But importantly, it doesn't represent the devices. It tracks the time that the players are spending in the room and adjusts the difficulty based on the time that they're spending. And it can also change the complete flow of the room. If you want to think about it as an analogy, this distributed state machine is like a conductor in an orchestra. I need more strings, less percussion. I need to, oh, the harp, I can't even hear you, you're out for now. The conductor isn't playing the instruments themselves, and the violinist only needs to listen to what the conductor is telling them to do. They don't have to know what the conductor is going to tell them to do. They just need to go, oh, more, allegro, or whatever it is. So the conductor in programming patterns is typically known as the process manager pattern. In .NET, we call that sagas. I'm sorry, you can't see the link at the bottom there. Oh, you can. I can't see it on that one. So the process manager pattern, if you implement this, it's a great way to do this. Or you can use the actor model. Alternatively, you can use the routing slip pattern to implement this. The routing slip pattern is quite a bit harder because you have to define all of the flows up front before you send that initial message, whereas the process manager and the actor model can change. They can make decisions on their own. So we've got these devices talking to each other via MQTT, and we've got this conductor in the middle. And remember, the conductor doesn't have to know about the individual, how the puzzles work. It just needs to know that you need to be easier, or you need to be harder, or you're out completely, or you're back in. Let's take a look at working around limitations. So like I said, MQTT is nice, but it does have a few drawbacks to it. Specifically, the ones that are important to us are it's not actually a queue, and it's got a slightly smaller feature set. The smaller feature set is problematic when implementing a process manager pattern, because a process manager pattern can really benefit from being able to support delayed delivery on messages. So at the start, you send messages every 5 minutes to go and change the difficulty based on where they are. MQTT doesn't support that. It also doesn't support time to be received, so you can't discard messages that are no longer valid. And you can't queue up messages, which means you can only ever send one, so you have to have this bit of logic running the whole time. And MQTT is surprisingly difficult to monitor, probably related to its one queue count thing. What would be really nice is if we had the devices talking MQTT, and we had our process manager talking a real broker, a more fully featured broker. And you can do this by implementing the messaging bridge pattern. So the messaging bridge pattern takes messages from one transport and knows how to shovel them through to the other transport. Now, I work for NServiceBus, or for particular, and we make NServiceBus, and NServiceBus has a built-in messaging bridge, so I just use that for this escape room. And what it does is it says, well, I know that there's these events on this side, but I don't necessarily know what transport they're using. I just know that once something happens there, I need to get it on this side in this specific bit of code. And this is really powerful because you can add functionality later on, and the messaging bridge pattern will take care of making sure that those new subscribers get published when the messages come through. It's also very powerful for modernizing legacy systems. What do I mean by this? Well, if you have a system running on MSMQ, first of all, my condolences. Second of all hope is not lost. If you have a messaging bridge pattern, what you can do is you can then have those components talk into the messaging bridge, and the messaging bridge can then talk to a more fully fledged or new or more modern technology, such as AWS SQS or Azure Service Bus, whatever it is. And then you can deploy new functionality in your system, deploy it talking to the new technology, the new broker. The messaging bridge takes care of making sure that the publishers in the old system go to the correct endpoints in the new system. And all that the code needs to know is that logically something is going to publish this event. Or logically, I need to send this command to this logical thing. And the messaging bridge will take care of knowing whether or not that's in the old MSMQ or the new SQS. The very, very powerful feature. So we've got our system working with this. We've got our devices talking MQTT. We've got our clever application talking RabbitMQ, and everything's working great. Those are sort of the 4 big clues. And now let's take a look at how it went. So constructing the escape room was pretty fun. This is me creating the 2D spirit puzzle, the balance puzzle. This is probably about the 5th or 6th iteration of the spirit puzzle. I was very sure that this was the last time I was going to have to print this. As you can see, I'm using a new strip of LEDs there because I was so confident. About 5 seconds after this photo was taken, I realized that I forgot to include the holes in the model for the power lines to go through and the data lines to go through. So we were on to iteration 7. The musical tone puzzle went through many iterations because I wanted it to have a nice small form factor, but I just couldn't get the strength that I wanted out of the 3D model, so it kept breaking. That was painful. There was a lot of blood going on. You'll notice behind the censored blocks, which is where the blood is, I also have a plaster on my thumb already. A fresh plaster, so it's not the first time today, or on the day that this photo was taken, that I managed to cut myself. When soldering things, I am a terrible solderer. I don't know, that sounds really weird. I am terrible at soldering things. I'm also terrible about planning things in advance. So as you can see, these 2 buttons need to go through these 2 holes. I have already soldered a common wire between them on 5 devices. I had to unsolder all 5 of those devices. I burnt myself while soldering. I melted the soldering iron's cable using the soldering iron. And I did have a picture here of my keyboard, but after seeing the keyboard user group, I feel like my safety might not be secured. I soldered 2 holes into my keyboard as well. So the picture was taken out. But eventually I got the room constructed and I was ready to run this thing. And I thought, you know what? These children are great. They're going to be fantastic. These are going to be the Goonies of my escape room. They're going to come through. They're going to work together, overcome their differences, and solve the escape room. I didn't get the Goonies. I got them. This was not what I wanted. In fact, my wife took this picture of me. This is after the 3rd attempt of running the escape room with absolutely nothing working. My dog is loving this, by the way. But nothing was working, and my kids had invited their friends around for 3 separate occasions. This was very painful for me. And I still remember a little bit after this picture was taken, one of my daughter's friends comes up to me, and she's tiny. She looks like she's about 3 or 4, but she is slightly older. And she comes up to me and stands next to me then and puts a little hand on my shoulder. And you know, children are very kind, I think, and they're very sweet. We seem to lose a lot of that as we grow up. So this little sweet child puts her hand on my shoulder and says to me, maybe you should have tried harder. And it took a while for me to realize the kindness for what it was, because I did have to try harder. But eventually, we got it right on the 4th attempt, and I managed to run the escape room for the first time. And here's a few pictures of the kids doing the more physical puzzles, because we've seen them play with the more IoT ones along the way. And they had a great time. It took them 1 hour and 6 minutes to finish, so a little bit behind schedule, but I think it was fairly well adjusted for them. They eventually managed to get whatever they want out of the box. So the things I'll take away from this, and the things that I'll remember from this experience, is that when you monitor systems, even if it seems like it's a simple system, it pays to be intentional about what you're monitoring. Think about the things that you're monitoring, why you're monitoring those things, and see if you're getting duplicate information. Because if you're monitoring and you're not getting new information, you're wasting your time monitoring that stuff. Service boundaries are business rules, and thinking about service boundaries doesn't necessarily mean that you have to have these big things that encompass all things. Rather, think in terms of verbs instead of nouns. You're doing things within your service boundaries. Don't conflate aggregate roots with bounded contexts. If you can distribute state, it means that you can keep the simplicity in the devices. The devices didn't need to know about the rest of the escape room. They just needed to listen to what the conductor was telling them to do. And the conductor didn't need to know how to run all the devices. It just needed to be able to tell them, you need to be easier. You need to be easier. Polyglot messaging can be super useful, especially if you have legacy applications that you don't want to work on and that all work in fine in production. You don't necessarily want to break legacy systems by modernizing them. By using polyglot messaging, you can modernize them piece by piece without breaking them in production. But I think most importantly, what I remember from this is the impact it had on my children. My daughter on the left there is building a booby trap room at my parents' house while we were visiting because she was inspired by the idea of building an escape room. My daughter on the right, we started with magnifying glasses for looking for clues. That progressed to binoculars, and now eventually she's looking at telescopes, and we've got going on little stargazing camps together. So it's not just about the code and the system and the end product, it's about the experiences that you create. So sometimes it's okay to do the hard projects. because of the impact it will have and the memory that it will leave you with at the end of it. I think I'm about bang on time, so if there are any questions, I'll be hanging around for a few minutes. Did anybody get to do the escape from earlier today, by the way? 1, 2, yay! I hope you had fun. I sure had fun. Thank you everyone for coming.